Today, we're looking at a classic coding interview question called product of array except self. The problem goes like this. You're given an array, for example, 2, 3, 4, 5, 1. You need to return a new array where each position is the product of all the numbers except the one at that position. Let's walk through the example. At the first position, 2, the product of the others is 60. At the second position, 3, left is 2, and right multiplies to 20, so 2 times 20 is 40. The same logic gives 30, 24, and finally 120. What we just did is brute force. It takes 2 nested loops, which means the time complexity is O of n squared. But interviewers usually require O of n, so this approach doesn't meet the requirement. Some people might think, just multiply all the numbers once, then divide by each element. But that has 2 problems. If the array has 0, division breaks, and multiplying everything can overflow the integer range. That's why division is usually not allowed. So what's the smarter way? The idea is simple. For each position, the result equals the product of all numbers to its left, multiplied by the product of all numbers to its right. If we pre-compute those left and right products, the answer comes naturally. Let's build a left array, also called the prefix product array, going from left to right. The rule is simple. Each entry equals the previous product times the previous number. At the first position, there's nothing on the left, so we put 1. At the second position, it's the previous product 1 times the previous number 2, which gives 2. At the third position, it's the previous product 2 times the previous number 3, which gives 6. Continue the same rule, and you can fill out the whole left array. This avoids repeated calculations, and each step runs in constant time. Next, we build a right array, also called the suffix product array, but this time from right to left. The rule is similar. Each entry equals the next product times the next number. At the last position, there's nothing on the right, so we put 1. At the second to last position, it's the next product 1 times the next number 1, which is still 1. Keep going forward, and you can fill out the right array. Finally, multiply the left and right arrays element by element, and you get the final result. The Python implementation is pretty straightforward. We create 3 arrays, left, right, and result, all starting with 1s. Then we run 3 loops, first to compute left, then right, and finally multiply them together. Each loop is O of n, so the total time complexity is O of n, and the space complexity is also O of n.